Python and Rust are two different beasts, but they are more complementary than you think. In today's video, I will show you how Rust is making the Python language, its ecosystem, and the developer experience better. After this video, you will hopefully be happy as a Python developer to see Rust coming into the world of your favorite language. We'll cover three main points. First, how Rust is making the Python tooling better. Then, how Rust is improving the Python libraries, and finally, how it's enhancing the Python runtime. Let's go! On one hand, we have Rust, which is one of the best languages to build tools and libraries. It gives you access to fast execution, memory safety out of the box, fearless concurrency, and an excellent expressivity with its powerful type system. But all those powers come with a steeper learning curve. On the other hand, you have Python, which is one of the most popular languages with a huge ecosystem. It's also the king of the data science and AI world, mainly because of its simplicity, allowing scientists to write code without being software engineers. Python traded static compilation for dynamic interpretation, leading to slower performance, but faster development cycles and ease of development. Because of its low barrier of entry and dynamic typing, Python is more prone to writing bad code. So we start to see a complementarity between those two. Use Python for fast development and the access to huge ecosystem including AI technologies, while relying on Rust to build robust tooling and libraries. Now that we introduced the topic, let's first dive into how Rust is improving Python tooling. Writing code is an important part of the software industry, and so improving the developer experience has many benefits, such as writing better code in a shorter time. And to do so, there is an excellent group named Astral, which is building the next-gen tooling for Python in Rust. They build three different tools: Ruf, UV, and Rai. Ruf is a code linter, formatter, and import organizer that runs at the speed of light. It's pretty convenient because if you're a Python developer, you likely use Black for formatting, isort to sort your imports, and the linter such as PyLint or Flake8 to lint your code. But with Ruf, you get all those three features in a single CLI that runs super fast, as you can see in the following video. So, Ruf takes 0.16 seconds to lint the entire CPython codebase, compared to PyLint taking 60 seconds, and even if we compare to the second fastest, AutoFlake, the difference is significant. The next one is UV, which is a drop-in replacement for pip. You can use UV-pip install to install the package, UV-pip compile to generate a locked requirements file, and UV-pip sync to synchronize a virtual environment with a locked requirements file. It also has additional features, such as alternate resolution strategies. By default, Python will try to resolve dependencies to the highest compatible version. But with UV, you can change that behavior and, for instance, resolve to the lowest compatible version. It also supports arbitrary Python versions. By default, pip will try to use the current Python installed version to resolve the dependencies. But with UV, you can specify an arbitrary Python version. And finally, it supports dependency overrides, which is super useful if you need to change the declared dependency of a package. Now, if we look at the graph on the left, it shows the time to install the trio dependencies with a cache to simulate recreating a virtual environment. And as you can see, UV is beating the competition by far, thanks to the Rust implementation. And the last is Rai, which is more of a package and project management tool similar to Poetry. It will use the pyproject.toml file and create environments for you, while using UV in the backend to install packages. So, it's supposed to be super fast and also has the long-term vision of building a cargo for Python, cargo being the excellent package manager for Rust. Rust is also significantly improving Python libraries. Python has tons of available packages, but Rust allows us to build robust and performant libraries to improve the overall quality of the ecosystem. We are going to see three of them: polars, tokenizers, and ORJSON. And PyOS3 Maturin, which is a tool that allows Rust developers to easily build modules that can be installed and used by Python developers. The first one is Polars, which is kind of a replacement for Pandas, powered by a multi-threaded and vectorized query engine. Now, if we look at the competition, being Modin, Pandas, Dask or PySpark, Polars can be up to 50 times faster. The benchmark used is TPCH, which measures different data wrangling tasks. Now, thanks to the Rust implementation, Polars is the fastest due to parallel execution, vectorization using SIMD, and efficient algorithms. Now, if you look on the right, you can see how it works. You import Polars and you create a pipeline of transformation. Then you call the collect function to get the results. The interesting part here is that Polars by default has a lazy API, meaning that the query that you are creating here is not executed right away. Polars will first run optimization like SQL does when you make a query to optimize the performance of your transformation. And when you call collect, you will get the results. Then we have tokenizers. Tokenizers is a library written by Hugging Face to tokenize text. Now, you most likely used ChatGPT, and the text needs to be represented as token to be consumed by the model. Tokenizers is precisely a library to do that, and it's super fast thanks to the Rust implementation. You can tokenize 1 GB of text in 20 seconds. Now, with tokenizers you can tokenize text, but you can also train your own tokenizers, and they implemented a few different algorithms to tokenize the text. Lastly, we have ORJSON. JSON is one of the most popular formats to communicate between servers and clients. So it's really important to parse and serialize JSON super fast, and that's precisely what ORJSON does thanks to the Rust implementation. If we compare ORJSON to the competition, we see that it can be 46 times faster. In two cases, on the left, we serialize a JSON catalog as compact, so approximately 500 kilobytes, or pretty, approximately 1 megabyte. ORJSON takes only 0.59 seconds and 0.71 seconds in both compact and pretty cases. Compared to the competition, it's super fast. Again, thanks to the Rust implementation. Now I want to quickly tell you about PyOStream Material, which is a tool to build and publish Rust-based Python modules with minimal configuration. So you write your Rust code, like here on the left, and you use two macros, the py function and py module. Py function helps you mark a function as available for the Python code, and py module helps you register multiple functions under a single module. Then you can export a wheel that you can install in your Python environment, and then simply import the module and use the function. It makes it super simple for Rust developer to build libraries for Python. So if you know how to write Rust, give it a try. Finally, Rust is also improving the Python runtime itself. Python is an interpreted language, meaning that it needs a runtime to read the code and execute it. The most popular one is CPython, but there is an effort to write a runtime in Rust, and it's called RustPython. This runtime has many benefits. First, it has an interactive shell for executing Python code within Rust. Then it also supports closures, modules, and the Python standard library. Thanks to Rust's excellent support of WebAssembly, you can also compile the runtime to WebAssembly and execute Python code in the browser. Finally, it also provides an experimental just-in-time compiler. So if you have a function here, you can call the JIT method on it that will compile the function to native code and make it super fast for the next execution. Now you can see how Rust is making Python better at 3 different levels: tooling, libraries, and the runtime. If you are a Python developer, I invite you to try Rust. It's a great language, and practicing low-level languages develop skills that will make you even better at Python. And if you are a Rust developer, make great tools and libraries for Python. See you in the next one.